Hello, my name is Jesse Schottner, and I'm completing the Fluent Flow Simulation Assignment 1 for Dr. Osbay's Fluid Mechanics class. I will be doing this assignment with Connor Freed, so I'm going to do the Poiseuille flow and Couette flow individually, and he will be doing the combination just with the same values and same setup. So as you can see here, I already have a few things that I've done already, but we're just going to start fresh. So we're going to go to Fluid Flow Fluent and create a standalone system. And I'm just going to name it Poiseuille Flow, Poiseuille Flow 2.0 for my own reference. I'm going to click on geometry first and make this 2D just so it knows we're in 2D already. Then we're going to open in Design Modular because I think that's the best one. And just give that a second to open. Alright, so we're here in Design Modular, and what we're going to do is just go to the XY plane and target that here so it's easier when we set up for our sims. And we are going to sketch a rectangle. That's pretty basic on here, so we're going to click XY plane, sketch, go to sketching rectangle, just make an arbitrary one right here, and then we'll add dimensions of horizontal and vertical. Oops, why did that not? There we go. And we're going to go down here and edit our values. So the values I'm going to go with, it says use L equals 150H on the assignment. So I'm just going to go based off of that. Yeah, so we're going to do, for our height, we're just going to do, which is our H1. Actually, no, our height is V. Sorry, we're just going to do 10. Actually, hold on, I have to change my units. We're going to go to millimeters. So yeah, we're going to do 10 millimeters for our height. What's going on here? Hold on. Okay, so we switched our height to 10 millimeters. We're going to change our length, and we're going to do 10 times 150, so it's going to be 1500 millimeters, because again, in the assignment, it tells us to do that. So we're going to zoom in a little here, just to get a better view of it. So there we go. Sweet. So we have 1500 meters and 10 millimeters, and it should be good. And now what we're going to do is we're going to create a surface from the sketch. We're going to concept, surface from sketches, and we're just going to click this base object here. So hold on. And we're just going to click sketch and apply. Then we're going to generate, and as you can see, our sketch is there. So that should be good. We're going to exit out of design modular. It's going to give us a check mark as a save, and then we're going to go over to mesh, which is going to open it in a similar thing. Give that a second to load. Alright, so the first thing we're going to do is create some name selections. And when we do that is we go to geometry, we click on this and our edge, we're going to create name sections. This is going to be our upper wall. This is going to be our lower wall. Have, because it's so long, we're going to have our inlet, and we'll have our outlet. Alright, and we'll go back to our main view here. And as you can see, we have all our things. So now we're going to go to our mesh. And the first thing we're going to do is we're going to add a couple of sizings. So we're going to add a sizing here. So what we're going to do first is we're going to do a sizing with the top and bottom. So we're going to select our geometry, go there. We're not going to use, actually, we'll use number of divisions, and this is about 300 meters long. So let's do about 3,000 divisions. We'll turn capture curvature off, and we'll make this hard. And that should be good. And we're going to click generate. This might take a second or so. Alright, so our mesh is done for that. So if we click on mesh, you can zoom in, see it's all these wonky shapes. It's about 3,000 divisions across. And we're going to create another sizing here. And this time we're going to apply it to the inlet and outlet. Oops, there we go. I'm going to apply that geometry. We're going to do number of divisions again, and because we are not at like 1,500 millimeters, we're only going to do about 50 divisions here. Capture curvature off, because there is no curve, make that hard. And that should be good. We're going to generate the mesh again, and give that some time to do that. Alright, so that created that new mesh. If we zoom in, you can see it's a little finer, but we still want to make it a little finer. So we're going to add another mesh, and we're going to do face meshing. And we're just going to select the surface here. Everything else should be fine. There's a lot of different things you can change for it, but we're going to keep it in quadrilaterals. And then we will generate that as well. And that one was much quicker. And if you see, we zoom in here on the mesh. Sorry, something came up in the corner. And you can see it's much finer now. And our mesh is good. So we can go back here and leave it there. We can exit out of our mesh, and then we can go into our setup. So we're here on our mesh, and you can see that this is a lightning arrow. So if we update this here, we'll give it a second, and it should become a green check mark. Alright, cool. So that makes our mesh complete, and now we're going to go to setup here and start actually putting our fluid in. So we're going to do double precision for better results. And the maximum solver processes we can use on Ansys Student is 4. This computer has 12 core, so it's 24 max, but we can only use 4 for the student version. So we're going to click start, and it's going to set up our setup tab. Give it a second to load in. Alright, so that looks good. And what we're going to do here is a few things. So first thing we're going to do is a Poiseuille flow. Hopefully I'm saying that correctly. And to do that, there's a couple things we need to set up first. So multi-phase needs to be off. Energy needs to be off, which I believe will keep it in incompressible and ready to go. And we need to change our viscous here. So we are modeling against laminar, K epsilon or K omega, whichever one it's on. Yeah, that's for turbulent. So we definitely don't want that. And then all of that's good. And we're going to go to materials. And the fluid they give us is air, but I don't want to use air. So we're just going to go into here and go to Fluent Database. And I would like to choose water because it is, always incompressible. Or, yeah, incompressible. And we're just going to use copy here from our water liquid. And that's going to bring our Fluent back here. And as you can see, our density is, we're just going to keep it what it gives us in the viscosity. It's around, if you look up online, the density temperatures tables of water. This is about the temperature and dynamic viscosity at somewhere between 20 and 25 Celsius. The the density is around 1,000 kilogram per meter cubed, but we'll keep it at this and this viscosity. So we'll close that, and what we'll need to do is go to cell zone boundary here, click edit, and we're going to need to change this to water liquid, and then we'll click apply, and then we'll go back to fluid and delete our error so that doesn't make any mistakes. So our cell zone is good. We're going to move over to boundary conditions, and again, we're going to do Poiseuille first. So to do that, we're going to need a velocity at our inlet, and the velocity we're going to go with for today is 0.1. And if you calculate your Reynolds number with the density and viscosity that I just showed, with the velocity and diameter or the characteristic of the pipe, you get around 970 Reynolds number, which is, in that laminar flow region that we want. So we're going to click apply, get that going. Let me check outlet. This should be pressure, should be 0. That's fine. Something else we're going to do is just when we go to inlet, that's good. We're going to go to outlet. We're going to prevent reverse flow so we don't have any issues with that. Lower and upper wall, we're going to check to keep them stationary. As this is not Couette, there is no shear or velocity moving at the wall. So that looks good. We're going to go to reference values and reference it from the inlet so everything stays consistent. That looks good. And that should be pretty much it for here. We're going to click initialization to get our calculations ready, and we're going to run calculations, and you can do as many as you want. The more iterations you do, the longer it's going to be, more processing. We're going to do around 200 iterations, so this is fairly quick. As you can see, that's going to keep running, and I will be back when that is done. Okay, so that was pretty quick for what it's worth. And now that we're done in the results tab, or the setup tab, we're going to click out and go to the results tab and give that a second to load. And as you can see, our check marks are good to go. So we're going to go to results, and we're going to click edit. And as of now, we have nothing showing because we haven't added anything yet. So the first thing we're going to do is add our midlines and end lines so we can show the velocity profiles at those, and the maximum velocity and maximum height. So first we're going to do midline, and that's going to create here. We're going to do it's about 1500. Actually, is it 1500 or yeah, it's about 1500. So we're going to divide by 2, make that 0.750. This is in meters, this tab, but we're just going to keep it like that. So 0 under 750, which is meters, 750 millimeters, and keep that sample. That should be good. We're going to apply that, and if you can see, oh, I forgot to do the height, 0.1, 0. Assuming it's very small. Give me 1 second. Okay, so I forgot how this works. And I was putting the same value, so it was just giving me a point instead of a line. And as you can see here, there's a line going from 0 to 0.01, which is our height. And that should be good. So we're going to go to location, and we're going to add another line, which is our end line. And because this goes 1500 millimeters, we're not going to do all the way to the end because I've heard that can give some bad results, and I've played around with it. So we're going to do 1499, which is 1 millimeter off from that. And the same process here, we're going to do 0.1, and we apply. And that should be good. And if we zoomed in all the way here, it is not showing because I forgot to put a point. We put a point. Boom. You can see it's right there. So we're going to go back here to our regular shape. So our locations are there. And now we're going to actually add our velocity contour so we can see that. So we're going to add velocity contour here. And first thing we're going to do is switch variable to velocity u. So it's our velocity in the x. And number of contours to 110 so we get more things there. Everything else should be good for now. So we are going to apply that. And you can see, well, it's not on there. So we need to, I apologize, we have to do inlet, and we have to do symmetry 1. And then we apply that. Now it will give a second load, and boom. So if we look at this, you can see it is developed it somewhere. So this is very long, but you can see the pipe is developing in the very beginning. And, oh geez. and it gets developed and it stays pretty consistent across the entire thing. So that is pretty nice. And what we can do is, this looks a little ugly, so we're going to edit here. We can go to appearance, we can change this to fix, and we can move this to horizontal and apply. And we can do it like that. So that's going to look really nice. And let me put that back there. We're going to move this up here as well. It's obviously very big. So what we're going to do is just leave it like that. But you can fairly see that it stays consistent at a certain level. And then what we're going to do is go to chart, which is this one. And we'll do velocity profile name for a chart. And as of now, we have absolutely nothing on there, but that's because we need to add our data series. So we want to show maximum velocity at, we're going to show the profiles at the mid and end section. So we're going to add a mid section, which we're going to call midline section, just to give it some stuff. And we're going to go here and do end line section at our end line. And if we look at here, should all be pretty chill. But what we need to do first is our x-axis is going to be our velocity u, and then our y is just going to be our y, because we want it to model how it's going to look at the pipe. So if we click apply, you can see they are basically the same. And the reasoning for that is the flow is fully developed around here, right? And at this point, the midline and the end line are literally the exact same velocities because it's already fully developed and it's in that laminar flow. So it's going to be the same exact values for each one, which is nice. You know, it looks cool and looks chill. Um, and yeah, I'm going to export those values to my document, and then I will come back and do the Couette flow. So I will see you in 1 second. All right, so I just finished exporting all that values. So we can close out of here, and we're going to go to our Couette flow. And what's really nice about, oops, those are not the right values. Ignore that. That's an old document. And what's really nice about Fluent here is we can just move out here, add another Fluent case, and instead of going back in and changing the setup so I can save those results, we can just transfer our geometry and our mesh here. So it is the exact same geometry we built and the exact same mesh we built, so we don't have to do any of that again. But now we can change our setup. So we have a separate for Poiseuille and Couette. So we're going to go here and do double precision. Now we will have to put in, you know, the water again and some other values, but it doesn't take too long. And it's nice just to have them separate so we don't have to redo something to get back to where we were. It's going to load for a second. All right, very nice. So we're switching from Poiseuille to Couette. So we do not want our velocity to be 0 at each plate. We want our velocity to be driven by a plate, actually. So we're going to click OK. We're going to go to Models, Multi-Phase Energy are good to go. This needs to immediately change to laminar. Everything else looks good. We want steady state. Everything else is fine. So we're going to go to Materials. Do the same exact thing we did before. Fluent Database. Scroll down. Water, Liquid. Copy that. Close. Check here. Boom. It's the same values we had. We are going to go to Cell Zone. Surface Body. We would like to switch that to Water. And again, this is personal preference. You can use air or liquid. Doesn't matter which one. And we're going to delete air so it doesn't involve any issues. Now we're going to go to boundary conditions. So we need to switch our inlet from velocity. And the reason we're going to do that is we're going to go click on boundary conditions, click on inlet, and we're going to make this pressure. And that's to get rid of our velocity and make sure that doesn't do anything. So we're keeping it 0. That is exactly what we want. We're going to go to outlet, make sure it's the same thing. Yep, we're good to go. But something else we want to do here is to make it look nice and fresh is you're going to prevent reverse flow because this is a very long pipe. So there could be some reverse flow, maybe depending. Oops, that's the wrong thing. Prevent reverse flow. And the main difference we're going to do here is go to wall, go to upper wall, and we're going to add our velocity, and we're just going to use the exact same speed that we did before, 0.1. Keep it pretty low, keep it pretty standard, and that is moving wall. So that should be good. And we're going to go back to do the same thing we did before, reference values, everything from inlet, so it's consistent. Just checking something, just curious. Make sure that's saved. Sure did. So we're going to go to initialization and get ready to run our test. Initialize works, boom. Run calculations. We are going to do 200 method iterations again. We are going to calculate, and we will let that run. Should be fairly quick. I'll pause when it's done. Okay, so that was pretty quick, and we're done here. So what we're going to do is close out of our setup / solutions. They're basically the same tab. Your setup and solutions do the same thing, but as you can see, they both update. We're going to open our results, which is the same software we did before. And we're just going to do the exact same thing, right? So now we're in Couette, so we should make it a little different. But we're just going to go to location. We're going to go to line, midline. Again, you could have used the same file, but I like doing it in two different ones. So we save it all. We are going to apply that. And you can see that it fills up the middle. Perfect. Another one, end line. And again, we're going to do 1.499, just so we're at the end. Get rid of that 0 because it's ugly. And we're going to do 0.1, 0.01. And you can see it's all the way over there. So that's good. And everything else is fine. So now we're going to start with our contour, velocity contour. And again, this will just show us our velocity over the pipe. Switch the number 10 to 110 so we get a smoother look. Symmetry, the 1, velocity to you. Everything else looks good. Apply that. Let's take a look. Perfect. So as you can see, and this is a little different with water, takes a little while for it, takes a little longer for it to move. But before I show you that, let me just do what I did before. Did I just do before? Oh yeah, fixed. We don't want scientific. Yeah, it's cool. So as you can see, if we zoom in on this, it takes a little bit for the velocity to form because it's got to develop even though the velocity is moving. Oops. And you can see it gets fully developed here. Oh, I cannot move this. But once it's fully developed, it stays pretty consistent, right? The velocity at the top is your max. Oh my goodness. And the velocity at your bottom is 0. And you can see it moves along. And that's pretty nice. But obviously we want to look at the chart so we can make it easier. So we're going to go here is go back to chart, velocity profiles. And we are going to do the same exact thing we did before. So we can call our data series. We're going to do midline series. Pretty straightforward. Midline. And make our end line as well. It's literally the same process as before. It's not too difficult. And you could also add a line much further or much earlier in the pipe to show developing flow, and it will show difference on that. But we don't need to do that right now. So we're going to trigger X, velocity U, Y. This is our Y. That looks pretty good. Apply that bad boy. Oops. Forgot to put end line there. And we'll apply. And as you can see, it is somewhat linear. The reason it's not linear is because water, I believe, acts a little differently with air. When I used the air as a flow, it gave a linear pattern, but with water, it was a little different. But as you can see, it is increasing and decreasing the same way Couette would work. 0.01 at your max, 0 at your end line, and that gives you the whole setup. And that's pretty much it for all this. Again, Connor is going to do the Poiseuille and Couette combined, which, he'll build the thing again. He'll do a little bit different of a mesh maybe, but overall you should get the same values and should look similar. So yeah, thank you.